Welcome to the spring edition of the Fine Line Video Journal. I'm Jan Willis from the eBeam Initiative. And with me today, I have Greg McIntyre, who's the Director of Advanced Patterning at imec. Today we're at the San Jose Convention Center for SPI, Advanced Lithography, and we just announced that imec has become a new member of the eBeam Initiative. So welcome, Greg.
Thank you. Thank you.
One of the things that we do as part of all of the eBeam Initiative events is talk about how eBeam technology matters no matter what lithography option you choose. So I'd like to start there and ask you about EUV. How do you see eBeam technology being important to the success of EUV?
Yeah. So eBeam technology is definitely important to the success of not just EUV, but any kind of semiconductor advanced patterning, and has been for quite some time. From the wafer-based metrology and review, and more towards inspection, is clearly a huge enabler of any process technology, and EUV is certainly going to benefit from that as well. It's also, on the mask side, has always been a key part of mask making, and with the trend towards multi-beam mask writing, it's getting even more exciting in enabling what we need from the types of complexity in our reticles that we've seen in immersion with things like ILT and different types of advanced source mask optimization type schemes. But it's going to continue that trend into EUV as we start seeing sub-resolution assist features, and the complexity on our masks continues to get even greater and greater.
That's great. Well, one of the things that the eBeam Initiative does is a couple of surveys each year. And the 2016 survey highlighted that EUV pessimism had dropped to an all-time low. So I wanted to see what you thought were the big milestones that have been changing and increasing the confidence in EUV.
Yeah. So I think if you look at EUV over the past few years, so about 2013-14 was when the first tools started entering the market, the 3300s, and so it took about a year or so for that to sort of gain steam and people to start cranking out results. Throughout 2015, we had pretty much all of the major sites had EUV tools. We were getting 80 watts of power. People were showing somewhere around 500 wafers per day in 2015. That's gone up to close to 1,500 to 2,000 throughout 2016 into now. And so with that, it really enabled all the the people, all the folks within the ecosystem to start seeing wafers flow, to start seeing the ability to evaluate materials, and it really started to feel like it was a real thing. So I think that's a huge reason why the optimism about EUV really went up dramatically last year. And I think given the progress that continues to happen that you see this week here at the conference, that's, I think, going to keep moving in that same direction. So it's pretty exciting.
That's great. I'm going to stay with EUV for one more question because imec has many industry collaborations in this area. And one of the ones you announced last year is a joint venture with JSR Micro. So I wanted to see what's the update there?
Yep.
What can you tell us?
Yeah, so we're quite excited about that as well. So at the end of 2015 was this joint venture that we announced and started to launch, aimed at qualifying resists for manufacturing. So the basic idea is that there's a local production facility for small batch production. Then we use our facilities at imec, the scanner, to do quality control testing, ensure that the material is performing before it gets shipped off to the ultimate customer. So as we'll announce this week, we've made quite some milestones where we have initial pre-production batches that have already started moving, and we're well on the path to ramping up our activities throughout 2017. So we think at imec we have a path defined for quality control testing of at least the first materials that are likely to enter the market first. So.
Well, congratulations on all that progress.
Thank you.
I'm going to switch to DSA, or directed self-assembly, as an alternative lithography approach. There's been a lot of talk about it at the past couple years of conferences, so I wanted to see what your reflection was on how's the industry doing around DSA.
Yeah, so DSA, I don't think it's a secret that the momentum maybe has started to lose a little bit of steam compared to where it was a few years ago. There was lots of really good stuff going on over the past few years, and there still is. But despite the slight slowdown in momentum, which probably also has something to do with the the success of EUV lately, we do still believe that there are potential applications where it does make sense. And we have a DSA program that we continue, and we're focused on essentially three main areas. One is a technique that we'll show some nice results on this week, that's designed at making hexagonal arrays of holes, which are useful for the memory industry, the DRAM type applications. And the recent results there have been a dramatic reduction in the defectivity that we've seen with that process. So we think it has legs to potentially move forward and be useful in the memory sector. We also continue to work on the line space, really gearing towards making sure we can get the defectivity levels of the sort of previous processes down to acceptable levels. Although those processes may not see use in the industry, the thing that we're heading to is with the high Chi materials. So getting down to sub 20 nanometer pitch, which potentially has a number of advantages further down the road. And then the third application that we think still has merit to continue is really working hand in hand with EUV in order to help smooth some of the roughness that you see inherent to the EUV imaging with contact holes, vias, etc. So again, while momentum might have slowed down, it's certainly not gone.
Okay, that's great. That's good news then. So I'm just going to wrap up with one final question. I've really admired how imec has really become a beacon for industry collaboration, but I've often wondered, what's it like to work there, especially compared to a commercial company?
Yeah. So imec is certainly a pretty exciting place to be. I've worked in industry before and now at imec, and it has some extremely strong advantages to it. It really has evolved as a collaboration hub for the industry. So imec has always had our sort of core member program that was very chip maker focused, and we still do that. That's a big part of what we do. But over the past few years, we've also really accelerated what we call the supplier hub concept, where we've really pulled together all of the major suppliers and equipment, materials, masks, etc., to sort of build an ecosystem that allows us all to work together and solve some of the challenging problems that ultimately all of our customers are facing in their fabs, to try and get a leg up on some of those advanced processes. So it's pretty exciting. So it's a wide array of sort of activities that are common to the whole ecosystem, as well as a number of private, bilateral, trilateral, multiple companies working together to solve one problem or another. So it's a pretty neat place, and I think it continues to expand and grow.
That's great. With that, I'd like to thank Greg for his unique perspective on the industry and what's happening. Thank you for watching, and we'll see you next time on the Fine Line Video Journal.